Nice exponential problem under the root 7. We have 5 to the 16 plus 5 to the x over 5 to the x plus 5 to the 2 equals 5. Here, as you can see, you have a variable x. Here as well you have the variable x. So what is the first step to solve this? So what we are going to do is, first I'm going to write the radicand, that is the 7th root, and under that we have 5 to the 16 plus 5 to the x over, you have 5 to the x plus 5 square is equal to 5. Now to remove this root, what I'm going to do is raise this to the power of 7, and it should be raised on both sides, so here as well 5 to the power of 7. Now I can cancel out this root and the power 7, so I'll just have 5 to the 16 plus 5 to the x over 5 to the x plus 5 square is equal to 5 to the 7th. Now this is like a single fraction. What we can do in the next step is just cross multiply things. Alright, so we have 5 to the 16 plus 5 to the x is equal to, here I have 5 to the 7th times, I'm using parenthesis for this term, 5 to the x plus 5 square. Now the next step, we're gonna open the parenthesis. 5 to the 16 plus 5 to the x is equal to 5 to the 7 times 5 to the x plus we have 5 to the 7 times 5 square. Now as you can see, we have an x term, I'll just bring this term this side and bring this term the other side. Here I have the constants, this is as well a constant, so I have 5 to the x, when I bring it this side, minus 5 to the 7 times 5 to the x is equal to, when bases are same, there's multiplication, you add the powers. 7 plus 2 is 9. So I have 5 to the 9s for this one. And when I bring this the other side, I have 5 to the 16s. Alright. Then what I have next is, I have 5 to the x, 5 to the x. Let me take it out common. So 5 to the x times, here I'm left with 1 minus 5 to the 7th, which is equal to, here I have 5 to the 9s minus, I can write 5 to the 16s as 5 to the 9s times 5 to the 7th. When I add 9 plus 7, I get 16 back. So what I have now is 5 to the x times, I have 1 minus 5 to the 7th is equal to, now I can take 5 to the 9s common outside. So I'm left with 1 when I divide them, and here when I divide them 1 minus, I'm left with 5 to the 7th. Now as you can see, on left hand side and right hand side I have the same term, 1 minus 5 to the 7th. As they are getting multiplied, I can just cancel it off. So I'm left with 5 to the x is equal to 5 to the 9s. So when bases are same and there's equal to between them, I can just equate the powers. X is equal to 9, and that's our answer.